So the solar system, where we live. I said, Kiana, you may recall, we started out looking at the universe, Big Bang Theory, then galaxies, now solar system. So we're slowly zooming our way in. Hey, the next chapter we'll be looking at the Earth. Oh, okay. Definition of a solar system. Solar system is defined as a group of planets circling one or more stars. There are solar systems that have more than one sun. Not just on Star Wars and Tatooine and Luke's planet. There are actually ones out there. It says definition of a solar... Figured it out, Lena? There you go. Definition of a planet. A planet is a celestial, that's the fancy word for in outer space, body that orbits one or more stars. That used to be the definition of a planet, and so this definition is incomplete and it's going to lead to problems. So I'm going to give you the most recent formal definition of a planet, because we've been very casual with our definition of what a planet was. Some terminology. The Earth spins around its axis every 24 hours, and this spin is called its rotation. This is a very important word. Put your phone away, kiddo. Thank you. Face down, maybe even, to make me happy. Turns out the Earth rotates at 1,670 kilometers per hour if you're on the equator. So the Earth rotates, spins on its axis. That's what makes the sun appear to rise and set. Is the sun actually moving? No, it's us. But it looks to us like the sun is moving. Then, the Earth also revolves around the sun every 365 days, approximately. What do we call this revolution around the sun every 365 days? We give it a name. Nope. It begins with the letter Y. A year. We call the Earth's rotation a day. We call the Earth's revolution a year. And so every planet has its own rotation period called a day, and every planet has its own revolution period called a year. But they're all different from the Earth. The Earth revolves around the sun at 108,000 kilometers per hour. We're moving. We don't notice it, but we're moving. Yep. Yeah, and unfortunately, so we have revolution and rotation. I know they both begin with RO, but you do need to keep, those are going to be two vocabulary words on your test, I guarantee. What's the name for the Earth's spin that gives it a 24-hour day? Rotation. What's the name for the Earth's going around the sun that gives it a 365-day year? Revolution. Okay? Different planets have different periods of rotation, called a day, and revolution, called a year. One planet has a day that is longer than a year. One planet takes longer to spin around once than it does to orbit the sun once. For a candy, does anybody know which one? Kev?
Jupiter?
Nope. Nope. That was my I thought it was, and then I looked it up and I went, no. Turns out,
Saturn.
Venus, it takes 243 Earth days to spin. It takes 224.65 Earth days to go around the sun. It's a weird planet that way. We take for granted that a year is always longer than a day. Nope. Doesn't have to be. Hashtag nerd trivia. Put your pencils down. your pencils up. Our solar system formed around 4.5 billion years ago, give or take. What makes it up? Well, there are 4 inner planets. Most of you probably know this: Mercury, Venus, Earth, and Mars. They're also called terrestrial planets because that's the fancy word for made up of rock. The 4 inner planets are rocky. They are small, and they have solid cores and rocky crusts. Very different from the other planets. By the way, if we have inner planets, what do you think we call the other ones? Outer. Okay. In physics, we know how to name stuff. Okay. So Mercury, Venus, Earth, and Mars all have rocky shells, rocky crusts, and they have an inner core that's solid, not liquid, not gas. There are 4 outer planets. Jupiter, Saturn. By the way, it is pronounced Uranus, not the way all of you want to say for the joke. And Neptune. If you've ever seen pictures of these, they're gorgeous. Jupiter and Saturn in particular, they just look pretty. These are much larger, much colder, further away from the sun, and they have large gaseous bands. In fact, we call them the gas giants. Okay. There is a lovely summary of the planets on page 386 in your textbooks. I'm just going to show it to you right now. You're going to refer to, rather than me writing all this out, you can refer to it, but I'll show you where it is so that when you see it, you recognize it. So on page 386, right here, and 387, so it has lovely little bit about Mercury, Venus, Earth, Mars, lots of lovely information there. Jupiter, Saturn, Uranus, and Neptune, lots of information there. Pictures, and again, I always think that Jupiter and Saturn look very, very nice. Keep going. Because the distances in our solar system are so huge, astronomers use astronomical units, or AUs for short, to measure distances. 1 AU, 1 astronomical unit, is the distance between the sun and the earth. So when we say a planet is so and so many AUs away from the sun, what we're saying is it's that many times further away than the earth is. And if you want the actual number, it's about 150 million kilometers. That's, by the way, 150 kilometers. Lexi, that's 1 AU. You can see this is why we go with AUs, because otherwise the numbers get really, really big, really, really fast. And yeah, whatever. Okay. Oh, that's also a great vocabulary word. What's 1 AU? What's 1 astronomical unit? The distance between the sun and the earth. By the way, it's the average distance because the Earth's orbit isn't quite circular. It's a little bit shaped like an egg. It's elliptical, so it's the average distance, but I didn't. Hashtag nerd trivia. The sun! The center of our solar system. It turns out the sun contains more than 99% of the mass of the solar system. The planets, the asteroids, and everything else is only about 1% of what's left over. The sun is big. Jordan, big enough that it's tough for me to wrap my brain around how big it is, especially because when you see it in the sky, does it look big? In fact, it looks almost exactly the same size as a full moon. And so there is a tendency just subconsciously for you to think, oh, it's about the same size as the moon. No, it's just so much further away. It's huge. It's huge. And it's made up of different sections. Put your pencil down. So that was a lot of information about the sun. Here's more than is required for the course. Here's what you're going to need to know. Parts of the sun. The corona. The corona is the outermost part of the sun's atmosphere. It's only visible during an eclipse. And it can reach about 3 million degrees Celsius. That's a word you're going to need to know. Then we have these things called solar prominences. These are huge, superheated loops of gas that erupt from the sun, but they don't escape the sun. They form, let's use a different color than red, Mr. Dueck. They're these huge loops of gas that get pulled back into the sun. But then, oh, and they're huge. There's the approximate size of the Earth. They're huge. But then, Lena, every so often, one of these solar prominences can break off and head towards the Earth. Sunspots. These are intense magnetic storms on the surface of the sun. And Kiana, they're slightly cooler than surrounding areas. Oh, sunspots is also a word you're going to need to know. You'll notice I didn't say you needed to know solar prominences, but there's another one you're going to need to know in a second. And they move across the sun. So astronomers, when they were building telescopes, how do you look at the sun through a telescope? You put like a piece of welder's glass or something really, really dark in front of the lens, and then you can safely look at the sun. And they noticed that as they observed these spots over the days, they moved and they went, oh, I guess that means the sun is not a solid ball. It must be made of something else. It's a seething, almost liquid-like, well, gas. It's a seething, churning sphere, but not solid. On page 384 in your textbook, if you have your textbook handy, you want to turn to page 384, because this, when I copied it, became pretty blurry. These are the parts, page 384. Nicole, you open your textbooks, page 384, please, kiddo. 384, under the B, 3, under the I, 8, under the N, 4. You might want to make a little note at the bottom of the page here. See page 384. Sorry, at the bottom of the page here. See page 384. That's going to be part of your study guide, Riley, because the color, I've already told you, the color diagrams, I've tried to reproduce them, and they just become smears on the photocopier, so it's a waste of my time. These are the different parts of the sun. Okay? Which ones are you going to need to know? Here's what I said. I'm going to ask you these parts, all of them in your homework, when you have the textbook for a reference. Use the diagram on page 384 to fill in the blanks. On your test, you're going to need to know the words corona, solar flare, and sunspots. So you might want to, at the bottom of the page, or maybe in the margin here, or right here, these are the three that I'm going to ask you. Corona, solar flare, and sunspots. What are solar flares? I didn't give you a definition of that. Hey, look at the picture on page 384. Solar flares, I'm going to come back to this. Solar flares are when these actually leave and head towards Earth. Okay? Let's head inwards from the sun. What are we going to run into now? Turn the page of your notes over in just a second, if you haven't already. Oh, put your pencils down first. Solar storms. Northern lights, are they related to the sun? They are from the sun's magnetic fields. I'm going to show you that video later on. Instead, Let's keep going. Pick your pencils up. Planets and the size of the solar system. So I'm repeating myself, but we have 4 inner or rocky planets. 4, you with me? Yeah. 4 outer or gas planets. Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. And they all have some cool things about them. Okay. Saturn has rings. Jupiter has the great red spot. Which one's missing? What used to be on this list and is no longer on this list?
Pluto.
Oh, Pluto. Poor Pluto. Pluto. Planet or not? Neil deGrasse Tyson, the man in the video that you watched the other day, was actually part of the planetary board that in 2004 decided Pluto was not a planet. And he's taken heat for that. He actually got hate mail from kids. Put your pencils down, look up. Here you go. It says this. He published some of these. Dear scientist, what do you call Pluto if it's not a planet anymore? If you make it a planet again, all the science books will be right. Do people live on Pluto? If there are people who live there, they won't exist. Why can't Pluto be a planet? If it's small, that doesn't mean it doesn't have to be a planet anymore. Some people like Pluto. If it doesn't exist, then they don't have a favorite planet. Please write back, but not in cursive, because I can't read in cursive. Your friend, Madeline Trost. Typing. My name is John Glidden. I am 6 years old, and my favorite planet is Pluto. I disagree with you that Pluto is a Kuiper Belt object. I think Pluto is a real planet, and I took a poll of 11 people. He's bringing science and data to Neil. See? The question was, what do you think Pluto is? A planet? A double planet? A Kuiper Belt object? I think it is a double planet, and everyone else thought it was a regular real planet that is very cold. I had a half day at school yesterday, so my mom brought me to the Museum of Natural History in the Hayden Planetarium. I wanted to see you so I could tell you this in person. What's he saying? I know where you work, right? That's what he's saying. I know where you work, and I'm coming to get you. Sincerely, John Glidden. But eventually, time heals all wounds, and people get over it. Dear Dr. Neil Tyson deGrasse, at first, remember all those kids that sent you bad letters? Well, I want to apologize all the things we were wrong about. We're sorry about giving you mean letters saying that we love Pluto, but not you. I'm very sorry. It'll be okay. Taylor, age 7. And then the last one. Dear Dr. Neil deGrasse Tyson, I know how you feel. We feel the same about Pluto not being a planet, but we just have to get over it. That's science. We need to learn about science. Science will make you smart. And then he drew a little picture of Pluto. From Siddick. Oh, you know what? I forgot to show you, not this one. Here's my favorite one is, nope. Am I missing one? No, these are all from the same one. There's a great one where someone drew a picture of Pluto crying. Pluto's little tears running on. And then, something historic happened just 1 year ago. Put your pencil down. So why is Pluto not a planet? What condition for planethood has Pluto missed? Does it orbit the sun? Yep. There are three conditions. This is the official definition of a planet now. You have to orbit the sun. Pluto does that. You have to have enough mass that you've pulled yourself into a sphere due to your own gravity. Pluto has done that. But the third condition is you have to be large enough that you've cleared your orbit out of other debris. You can put an X. Pluto has not done that. So I gave you the list of little check marks. That's where Pluto fails. In fact, Pluto belongs to an entire new category of celestial bodies. You know what? I'll do that in a different color because that looks like red. So this is the one that it's failed. I won't cross that out, but that's the one that's failed. Pluto belongs to entire... Oh, by the way, this was from 2 years ago. This was all 786 known planets because we've now discovered planets around other stars to scale. This was published in 2012. It's already out of date. Last year, there was 1,600 that we had discovered. When I edited this past fall, it was 1,700. When I checked 2 weeks ago, we had found 1,900. They're called exoplanets, planets outside of our solar system, orbiting other stars and counting. When I was in high school, we hadn't found any. Pluto belongs to an entire new category called dwarf planets, also called trans-Neptunian objects. Trans, beyond, Neptunian, Neptune. Stuff out past Neptune. For example, and I didn't include this in your notes because this is nerd trivia, Eris is a dwarf planet, and it's actually 25% bigger than Pluto. You see, the issue was we had to decide either redefine what a planet was properly and cap it at 8, or we would have been going up to 11 or 12 because we found stuff bigger than Pluto further out there. It was discovered in 2005. It's about 3 times further from the sun than Pluto. In fact, these are the dwarf planets that we have discovered so far, and they're small, so we figure there's more of them out there. So here's Mercury for comparison. There's Pluto, Eris, Ceres. We have an asteroid. It's an asteroid in the asteroid belt. We have a satellite right now that for the first time is taking pictures of Ceres right now, this moment. And there are 2 shiny things on the surface. We have no idea what they are. It's a big mystery. It's getting closer and closer to Ceres. We're trying to figure out what the heck is shining. Haumea, which is kind of eggy shaped. And Make, or I think it's Maki, because it was discovered in Hawaii. Okay. So we could either have added 1, 2, 3 more or capped it. So I give you the same message as our young writer. That's science. Get over it. Other components of the solar system. Asteroids. These are chunks of rock orbiting the sun, and they're found between Jupiter and Mars in what we call the asteroid belt. However, the movies portray the asteroid belt very wrong. You see it all the time in space movies. In Star Wars, Han Solo takes the Millennium Falcon through an asteroid belt, and he's dodging and he's weaving. Asteroid belts are nearly empty. They are not all that cluttered with debris. In fact, we send probes through the asteroid belt to view planets all the time, and Kiana, we don't even take into account having to dodge rocks because the odds of hitting a rock in the asteroid belt is essentially 0 because they're so far spread out. So when you see in the movies all this debris and the spacecraft dodging and ducking, no, it's garbage. Comets. Comets are big balls of ice and rock. They also orbit the sun at the far edges of the solar system. They're part of something that we call the Oort Cloud, named after the scientist who first hypothesized it. We think on the very, 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 very edge of the solar system. Remember the video that we saw said that when the sun started fusing, it sent out a big blast of solar wind and cleared out a lot of debris? We think that's all gathered in the Oort Cloud, and those form comets. Some, like Halley's Comet, have very elliptical orbits. Halley's Comet, or Halley's Comet, I think is actually how it's pronounced, comes by every 76 years. Came by in 1986 when I was 16. It was going to be a big deal, but it wasn't a very, very good view. In 1910, it was visible, I think, during the day, because the Earth actually passed through its tail. It came very close. The main difference is that a comet has a tail, and the tail always points away from the sun, not towards the sun, points away from the sun. Give me a second here. Of course, the real problem is going to be when the huge asteroid hits us in the year 2034. You guys hadn't heard that there's a huge asteroid that's going to hit us in the year 2034? Put your pencils down.